The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put him in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everyone and welcome. My name is Nathan, otherwise known as Old Man Builds. What's going on, guys? Man, some fun today, man. Got my gravity flyer project out. Thank you very much for that. I got the gravity flyer project out and I was able to, sorry, let me move this a little closer. I was able to tune it a little bit, and what I was tuning was I got the high voltage, and I went ahead and put the Tesla coil to it, and I got both of them to ring the same frequency. Now, the frequency for the Tesla coil dropped, and the high voltage rose. And what it was is I had to put less voltage in the high voltage side. So I got 12 volts, 2 amps that went in there. And then my Tesla coil, I was only running at about 13 volts, is where it was pretty good at changing it real solid. So it's high voltage leaching is what's going on. Is as soon as the Tesla coil is in there and connected to the bar, it's only a little bar like this, smaller than a candy bar. What was going on was it would put out like a, I don't want to say like a bubble around it. And I don't think bubble is the right word, but it put out a field that went out from it, and then it would take the frequency of the high voltage and change it to the frequency of the Tesla coil. What was really cool about doing this is that I'm using a Joule Thief as my ultrasound circuit so that, it'll actually dial it in the same way. Once it gets to the frequency that the Tesla coil's at, and it will, because the piezo itself is a transmitter and a receiver, so it'll bring in the frequency at that. I broke the negative on the bottom. So you'll see all the wires hanging out there. I put the negative on the terminal block. And the reason for that was is as soon as I did that test a while back, I had my wire go right through the center of my Tesla coil, and it was the negative. And what it would do is it would saturate that, and then I was able to amplify everything based on that. So I know that that's going to work. So I know that the piezo's covered. We now got the high voltage covered. We got the Tesla coil covered. Everything in there should start to line up the frequencies. No more problems with everything getting an offbeat frequency. It's all working out. The one thing I'm really curious about is the motors. I broke the negative on the terminal, which basically means, just both sides of the terminal is the negative instead of the positive. And I think that was wrong. And I'll just say this and the reason why. When you want to add more power to the motor, you're going to want to do it through the positive side, not the negative side, right? So I thought, hey, it's all negative. Let's just keep going with the negative thing. And I think I was wrong there. And I think the understanding might be to break the positive side. Now, we'll do a little testing in negative first, and then we'll go on to the positive side if that's what needs to be done. But I think what it's going to do is it's going to add more energy to the motor, and it's going to start to balance them both out. Nice. Yeah, I threw my back out pretty good, man. Well, I told the wife, she goes, her grandma passed, and I had to go over and help, like all family members do in moving stuff out. And I told her I'm getting too old for this, right? I just said my back's been having a lot of problems and it's going to throw it out. So she said, well, we have to do it. You know what I mean? So I went ahead and said, okay. And I knew it was going to happen. So for the next 3 or 4 days, it's going to hurt, but I'm going to have to push through it, man, because I got too many things on the plate. So it is what it is, man. You know what I mean? And it just stems out back to the back surgery I had. One of the discs, I think above it, is ready to go. And it just happens when you get back surgery and then you work too hard after that and you set yourself up for failure and all the rest. It is what it is. You know what I mean? And I've lived with it pretty good. It take about a week or so to go away. Hopefully, if I put enough heating pads on it and stuff, and stretch it out, and can't sleep in the bed, got to sleep on the recliner. Otherwise, it puts too much pressure in one spot. So it'll clear up. What's the bar cold? Cold. Sorry, cold. It's just a little bar. Let me see if I got a picture of it. Give me a second. I don't think there's a real name for it. It's just a bar. So here we go. We could take a look at it. It's just one you find at the Lowe's or Home Depot or anywhere else. I don't think there's anything special about it. Yeah, it looks like chaos, doesn't it? Complete and utter chaos. There you go, terminal block. So what you'll see is on one side, you'll see the thick black wire and thick white wire, right? Those are my high voltage sides, one positive, one negative. You'll see that I spaced them out. That's my Tesla wire, which is the red one right there, where the little cursor's going. The one to the right of that, real tiny, that right there goes to my piezo disc, so I know that that's going to get saturated. And let me see. This black wire here goes to one of my motors. And then on the far left side, I believe, is my last motor. So, yeah, that's pretty much where we're at. And you saw the results if you watched the video. What would happen is in doing this, you start to see the signal of the high voltage, right? As soon as we turn the Tesla coil on, you saw it interrupting it a little bit. Then as soon as we turn the Tesla coil up a little bit, and we weren't high, we were just at 13 volts, but that circuit's so good, you turn it on that much, man, and you're putting out a good field on it. So it's like just bringing in everything that's on that terminal block right there, and it's saturating it with energy. Now, the energy isn't harmful. We're looking for sparks and didn't see any. Didn't spark on the high voltage or nothing. No sparks on the plates. So we were able to transmit the frequency over the rest of them. Now, did that change the RPM? Again, I think that thing has to be changed from negative where it splits. And you can see it where I'm talking about it splitting, where I say I break it. It's basically meaning that one side of it should be connected to the other instead of being on the terminal block. And all I did was split it. And now it's able to be open with a piece of metal on it that any Tesla coil, the way we have it hooked up, will go ahead and hit it, right? So we're able to get that frequency into it. We'll see how the motors change. I think it's got to be positive that's flipped, not the negative. And that's my mistake. I think I was thinking something different. And then when I thought about it later, I said, you know what? In order to get it to move faster, I got to get the positive involved, not the negative. So, and it's because there's a little circuit inside your fan motor that does that. So I think that's why. Yeah, they're basically just antennas right there. That's about what's going on. Yeah. Yeah. So the whole goal with this was I was picking up energy, just kind of like rewind a little bit. I was picking up energy in my gravity flyer, and then all of a sudden I'd get an off frequency, and then boom, the energy would be gone, and it'd start over again. And it kept doing it to me. So I said, okay, this isn't going to last. You know, I needed to keep picking up the energy and store it, right? Just like a capacitor would. And I wasn't getting that. It kept cutting off every time it hit an off frequency. So now, if you saw the video, you saw that the frequencies match. Now we don't have that problem. Yeah, destructive interference. Yeah, just like John said, we don't have any more destructive interference. Now everything is pretty much harmonious. I just got to see the motors resonated together without this. So it was just about changing the speed on the motor just a little bit because the bottom takes forever to get around because of the magnet size. And it's on a weak fan motor, so it's not going to push it like other ones would. So maybe I go back to splitting that because I put them together. I'll probably split it again and run it. I think I'm going to get a better result that way. But anyway, that puts us right in line to where we need to be. Frequencies match. At this point, man, this is like let's just get it going. Now we got all the frequencies to match, we got everything going. This also means that when we push the piezo buzzer, it amplified both. So now we're looking at it if we're in the frequency and the Tesla coil is already attached to it and it's already running at a higher amount of energy because of the Tesla coil, because it's adding to the energy, it's not taking anything away, it's not canceling out. It's building up the energy in the high voltage to match that, but it'll also do it in the negative circuit for the piezo, right? Because it's a joule thief, but the joule thief works on a negative energy in order to saturate to amplify. So the theory is once I hit that button and I have it tuned, that thing should be a monster amount of energy hitting that thing now. I should be able to double what's coming out of it. So, I think there's just good things ahead for this. So kind of wondering why things might pop off the ground when he said it. You know what I mean? He goes, he first had this thing popping off the ground, then he had on one leg, and then he got it to lift. That's what Alexi said. Now I can start to see that makes sense now. Now there's more energy in there. There's an amplification in there. The energy doubles in negative as soon as you push the button. I've already proven that on the oscilloscope. So I think we're really close. And think about it. The same frequency again, and again, and then amplified. It reminds me of a resonance chamber. So I think there's something to be said about that. I built the STL for it and put it in there. I should put it on my Thingiverse account so everybody can have it. And then they could just buy one and hook it up just like I did. You don't have to use one of those. By all means, if you get those little connector things, I think the little white connector things, and then you screw them in, it's still the same thing. That Tesla coil is so powerful, it's going to saturate all of them. I don't think you're going to have a problem there. This is what I had on hand, and that I thought might work best to get the antenna mode going. So that's what I used. Yeah, well, I've seen it work on his videos without the shell. And I'll be honest with you, man, I wish it had a shell. There's no joke about that. I really do wish it had a shell. And it would make things a lot easier. But because I've already seen the field of this thing, I know it creates the outer portion, which the shell would have done for me. So I don't know that I'll need it, but it might be something that comes up later. Anyway, we got that thing to amplify with some power into it and get things going. It's just the next step. And what is kind of crazy is the way his set up, he had to be seeing the same thing that I am. And that's what gives me a good indication that I did things right. You know what I mean? Because I see the amplification and power on his as soon as he pushes a button and like it lifts slightly. And then you see the electricity pop on the ground. Yeah, I've seen that a lot. So yeah, we're definitely on the right track. Oh, let's see the downward curve. Hold on, let me put this up. The downward curve of the gravity is insane, and it's bend those fields around it. And the craft would take a lot of power. Well, again, if you're thinking of the world versus your little craft, then absolutely you're right. If you think of it the way I did, and you saw that it build a field bubble around it, then you wouldn't be thinking that way. You'd be thinking how much energy the field bubble hold versus what you're thinking of is how much energy of the earth versus that little craft. Two totally different calculations in how we're thinking about it. I don't think it takes very much energy because we're isolating it from the rest of the earth with that field bubble. Maybe how MPPT can sweep the image change, maybe similar to the setup and find resonance via the max amplitude. Well, here's the thing. You got to think about it like this. You're resonating the center disc at the Tesla coil, but now you got a second one resonating, so they're going to go together, right? Top and bottom disc resonate together. Okay, those are two resonate together. I should have a beat frequency between them that does not break the resonance. I was having a beat frequency break my resonance before. This time, because the Tesla coil is self-correcting, and everybody's seen it when they have my coil and they put their power cells too close to it, it tries to resonate with the power source. When it does that, it fails your circuit and it'll go from nothing to boom, all the way up to 20. You guys saw it on my last live that I did. It blew out my computer twice. So, anyway, what I'm getting at here is I should have that now built into the system to auto correct it, right? So the Slayer exciter is an autocorrect circuit. It'll resonate to anything that's nearby it. So as I have it in there and I have it on the center, I got two of the same frequencies, and then I should get two of the same on the disc, okay, within like a half wave, quarter wave, or a third wave. And then I should have a beat frequency that comes with it. That's what I expect. So yeah, we're going to find out. Yeah, his Beetle platform didn't need that much power to work. I honestly think it's a difference in how you see it. Where does the lift come from? He doesn't say. I mean, he says it in Russian, if you understand that. I didn't. But it's from the two plates. He does a little test and he puts let's say a CD cover, you know, those little covers that you get for a stack of CDs. He takes one of those, he puts water in it, and he puts a plate in there and hooks it up to his high voltage, right? Then he connects another one to his high voltage and puts it outside of it. And what he's showing is the amplification as he pulls them apart. Okay, that's what Alexi showed. That's where his lift comes from. That's the power. And we've seen that in other devices as well. That's exactly where he said it was. So let's see. The high voltage was directly from the platform. I could tell you in his it wasn't. It was split on the bottom, and I have pictures of it because Charlie C owns the original one, and it does all hook in there, and his instructions to put it together, they all hook in there. Let's see. Slayer Exciter is a dirty impulsor. Wait to open to be clean. Well, it kind of asks the question: does it need to be clean, or does it just need to fix itself? So, hammer to a bell, yeah. Well, I think the piezo is a hammer to the bell. To be quite honest with you, I don't think that the Slayer is quite that, because it can be amplified, and I've done it. You could double the amount of energy coming out of it, which, by the way, is a scary thing on that circuit. He chose a wood I've never seen a wood platform on that whole device. Okay, not sure what you're talking about on that one. Your Benefice platform was wooden, that was for sure. Let's see. Two-seater lives closer to the father to get more power. Yes. It's a physics thing. You put the plates as close as you can together, okay? They build up energy between them in the Casimir effect, and then you pull them apart, and it gives you a multiplication of energy. It's almost like a Townsend effect, but it has a stopping point. But it builds out that way, you know, for the first bit of distance. There you go. Yes. See, it's probably better that it's dirty. Just for that, it resonates everything. That's kind of what we were looking for, right? I mean, we were looking to isolate. I isolated it before, and it was junk. It didn't do me any good whatsoever. As a matter of fact, it made it worse. Parallel plate capacitor, pretty much, except for it has 3 plates. So, like an asthmatic, I hear a lot. Capacitor basically just means an open air capacitor, yeah, with 2 plates, and they go. What's the difference? You put a center plate in there in order to get the Tesla coil field in it. That's what he did. Otherwise, it would normally work as the same thing. So, yeah, you know what I mean? Right there. Okay, don't know where you're at, Jarvis. There you go. Okay, well then that explains it. Yes, Gorbanikov did that. Yes, much different. Let me see. What Tesla said, in order to get the maximum power of it, you have to tune the impulses to the circuit target to movement in the local area. Yeah, you do. What is going on, crypto? Really? Who the heck would do that? Yeah, we're all there for you, man. Just tell us what you need. Wow. I think that goes back to a conversation you and I had before, crypto. You got mad at me for 4 months, and it might be coming back. So, but I don't want to go into it again because I like us the way we are. Got to get a job again. Gotcha. Yeah. We'll just leave it at that. I don't want to. I don't want any bad relations. I like hanging out with Bernie, and I don't want anything come back on me. So, yeah. Okay. Embedded inside the aluminum disc. Well, you don't really need it. I mean, you think about it. The piezo itself is amplifying that capacitor that you're building in the center. I mean, it sounds strange, but it absolutely is. You're forcing the capacitor in one direction. So think about it. You have a capacitor plate right here, and you have a center plate. You are running the piezo 24/7. So it's pushing on the center plate itself, right? It's pushing it down. What happens when you let off the pressure on that? You see, I don't think people really understand that. It's positive on one side, negative on the other. But if you're always putting pressure and a downward angle on it, and it's maintaining the positive and negative, when you flip it back to flat, what is it doing? Well, it adjusts where the positive and negative are temporarily. When we look at that, we should look at where the electricity is going in what direction and why. That's the answer to the lift. That's all it was. You're going to find that in a lot of things. If you want to build, man, what's that one thing that they always talk about that should work, that looks like basically a trash can with a solid side? Every time they talk about that, that's exactly what they're trying to say is happening in that device. They're just trying to push it on one side and then have it come back and hit it and make it go and create propulsion. Well, this actually does it. That's kind of the trick to it. You have to see it opposite. I always thought, hey, it's off. I need a button to turn it on, right? So I can make it go. This guy thinks in reverse. So he thinks we'll keep pressure on it and hold it. And then when it pops, it'll change the field right there, right? I guess it's a different way to look at it, but I guess it might be better because you can't stop the piezo from transmitting and taking in the frequency. I mean, receiving and transmitting at the same time. So it makes sense to think about it backwards when you really get into it, because something like that has to be done that way because you can't shut off the frequency in it because it's picking it up all the time. So yeah, a little different. Yeah. So nice. Yeah. Got some Got some things that are a bit different in there. Yeah, dude, I'm looking for success here real soon on this thing. I had it popped off the ground a little bit before. I expect to see the same thing in it now that I'm not getting my energy killed. Um, hey, also, I just wanted to go over a little bit. We had talked last time I was on Friday, and we were talking about you know, oh, how do I say it? The electrical universe. We were also talking about physics, and I told you that it's energy. And I just want to clarify this for everybody. I think physics needs to understand what they're trying to tell you in the electrical universe. I also think that the electrical universe needs to understand physics. I think they're both wrong if they classify all the energy as electrical. Okay. I hope that makes sense to everybody. It's energy. So think about it in this way. If I told you it's heat, it's cold, it's electricity, it's the lack of electricity, it's the amplification of something. If I told you it's radiation, if I told you it's the radiant field, okay, all of that comes into combination here. All of it. It's all energy, okay? That's the difference. Electrical theory has a certain set of parameters based on electrical theory. Well, you're not going to go beyond the electrical theory because everybody and their mother raises their hand and says, that's not how electricity works. Okay. Well, I'm sorry, but there is more things into this than just the electricity. Now, do I think they both make a fair point? Yes. But I think they need to really understand each other and where they are because it's both right and wrong at the same time, and they classify the word wrong. And when you do that, it doesn't account for everything else that's in it. It's like trying to tell a person who puts in wires in your walls as an electrician how things are supposed to work in what your MOSFETs or your transistors or something. They're just clueless. They have no idea. It doesn't follow their electrical theory, right? But then if I told you how to make a cold energy circuit, and if you're over there building transistors and MOSFETs, it wouldn't make a bit of sense to you at all because you see things differently than I do, right? I look at it as the conventional transistors that they first built. What did they do? They put two sides connected to a semiconductor. As soon as the semiconductor got somewhat saturated, it switched the energy from one side to the other. That was it. It was a matter of saturation. Now, you could tell me about all the electrons and the holes and all that stuff that you want. That's kind of gibberish, to be honest with you. They can't even prove that an electron really exists. Saturation rate, you can prove exists, and that's exactly how they described the first transistors when they were built. It's only when people got a hold of them later that they started putting electrons and holes and things. So, look, I'm sorry, but there's a different way to look at it. And if you look at it the way the original one was built, you can see that there's a way to get around things if you know how to saturate things. That's a difference. You know, electrical universe is great, but when you want to apply, I don't know, say radiation to it, it's not in their parameters, right? It just isn't there. Now, does it show up all over the place? Oh, absolutely. But then when you look at physics and you say, okay, there's enough hydrogen fuel in the sun to last this amount of time. I don't know the last time you played with hydrogen, but the last time I did, it exploded in one big blast. It did not have a reserve. Sorry, any container it was in, it exploded. So, how do you get a reserve? Where is it hiding? Like, how does that work? I would like a competent answer to that. How does it work? Unless you're creating the hydrogen continuously in order to bond or to tear apart and blow up or whatever, there's no reserve. That's not the way hydrogen works. Hydrogen's very explosive. That sucker, boom, instantly, man, it blows up. So you can't tell me there's this much in reserve because there's not. It must be building hydrogen continuously. The only way to get to hydrogen continuously being built is through breaking apart and putting together a bunch of, how do I want to say this? They're not atoms. I don't know that it's atoms. It's molecules. You got to be able to break and build, but then it may go to an atomic level. I wouldn't disagree with that at all because there is a nuclear reaction going on in there. So, but that also has to do with pressure. In order for you to believe that there's pressure in there, you must believe that there's a field bubble outside the sun itself, just like the Earth has. That is electrical. That is not regular physics. So, like I said, they need each other. The both sides have to coexist. It's the terminology because physics people are real snobby. Let's just say it for what it is. You got to have this beautiful sweater, a nice little tie on and after it, and you got to have a fireplace running, and you got to look down at everybody else. That's all I've seen from these people. I am the most educated. That's what I see. Rarely do you get a couple that are really cool and down to earth and just shoot the bull with you. Mostly you can't use that term. That term has a very specific thing that it's related to. You cannot use any term like that because it has a specific meaning. Okay, I'm just generally describing something, but that's the way they see it. So that's why they don't like the electrical universe, because they're describing it in words that mean something else to them. I don't know. It gets frustrating. You could see the answer right in front of both of them, like literally right in front of them. Like, hello, it's right there. The answer's right there between you two. If you drop your arrogance, you'd be able to see it. I don't think that they really can do that, to be honest with you. That's why people say that physics sucks or it's fake or whatever. It's for that reason, because you can't explain it if you don't say at every other breath, the theory of this, the theory of that, the theory of this. I understand you're trying to back up your point, but there's not a whole lot of experimentation that goes along with that theory. That's where it falls flat. Electrical, there is, because you in physics use electricity in order to build these fields out. I'm sorry, you do. And then you turn around and tell them that they're morons because they talk about electricity. I mean, for God's sakes, man, I've never seen no more ignorant argument in my whole life. I mean, seriously, you know it's both. I mean, you know it's both. Down deep, you know it's both. Okay, and I just get really aggravated. That's why I don't talk in their terms. It's like, why bother? They just get aggravated. I have people doing spell checks because they want to learn the physics of something, or ask 500 questions on the same subject because you didn't listen before you asked the next question. It gets really repetitive and ignorant. So it's like I try to explain to them how to, this is how you do this, or this is how you change the circuit, or this is how you build this thing. And I could get resonance out of it. But for them, it's like, it doesn't work that way. The book says it doesn't work that way. There's no way, because the book didn't say it does this. My teacher in this school just said it didn't work that way, so it must not work that way. Really? Really? You didn't spend the $100 to build it to find out, like I did? I mean, why not? I just don't understand that. The thinking doesn't make any sense to me. So, yeah, anyway, that's what I was just trying to clarify that. Look, I'm not dissing anybody's opinion on stuff. As a matter of fact, I think it would promote both sides if they always went back to it and said, okay, this is the experiment. This is what it showed. We can extrapolate all this from it. So it goes in this column, right? Then we have a yes and a no column next to them, and you keep it in this column until you can get to the yes and no. That's what I do when I evaluate things. I say, okay, I'm thinking it's in here, it belongs, right? And then at certain points, I put it on the outside. No, it doesn't belong. Sometimes I put it on the inside. Yeah, it does belong. And then you come out with different things. If this goes to this, then this belongs. So anyway, yeah, there's a lot there, man. Have you seen the 3 videos on the hourglass that shows how the sands fall supposedly at different time when exposed to a strong magnetic, regardless of the magnetic place? So what do you think? It goes into a field flip. Yeah. I keep telling people you got to realize the field you're in. You're in a radiant field. You want to flip that over to a field that you can get into. You want to flip it into a magnetic field. What do you need? You need heat based on magnetism. That's what you need. It's not just regular heat. Yeah, you can see the heat in a hot air balloon, but when it happens with magnetism, now you can really see it. It starts to change things. And what does it also have to do? It has to rotate and accelerate. That's what it has to do. So you wonder why you have counter rotating directions and stuff. That's why, number one. I mean, there's a lot of variables to some of this stuff. Sans is the piezoelectricity going on in there because you have a bunch of quartz in there. Quartz itself, you know what I mean? It needs a little bit of water and a little bit of energy to it to create a negative energy inside of it. But I don't know that I buy it that it was just sand going in a magnetic field. Okay. Unless, okay. And there's one caveat to that, and only this one. Any piece of quartz has a magnetic side to it. Yeah. It passes through a magnetic field, it will slow. But your magnetic field has to be, I mean, of sufficient value to get that to happen. And you have to have the quartz where it's actually going to be able to slow it. That's the only way that works. So, yeah. Right on, brother. MIT is awesome, man. I do like a lot of stuff. Well, thank you. Guys, I'm not saying that I dislike anybody. I mean, I can't tell you that how many people I get along with. It's not about that. It's about just listening to what's going on. If we can get people to share the ideas back and forth, then we're good to go. I share mine freely. I don't have a problem doing that. A lot of people hide them, and that's caused a lot of problems here in what we do. I have zero issues with people. Okay, I don't care which side you're on. Just understand that. I just don't. I don't have time for it. You know what I mean? I got things I want to do, and to argue with somebody for hours over something's not worth it. I think honestly, man, like I said, just open your eyes to what's going on, and as soon as you do, we all need each other to get through this to get the right answer. I found that, you know what I mean, a whole lot more than I did anybody who said, they knew too much. So, yeah, I think experimentation is the way to go. MIT is about experimentation, though, isn't it? It's about setting up the experiments, about doing the work. It's about showing the result. It's about challenging every single thing that comes out as a theory and then seeing if it works, right? It is literally building the experiment to the theory. So sometimes it's really hard. Sometimes building the experiment's easier than the theory itself. You know what I mean? So as far as I know, that's what MIT does. They build out things. So yeah, I think that's exactly the way to go. So right on, brother. Yeah, I appreciate it. Thank you for that. So yeah, well, I mean, I guess we all kind of like what I mean, all do the same thing, right? We build it, we say what we see, and then somebody else will come along and change it, and that's all right. But we're just getting out what we see, you know. I think one of the cool things would be to have a physicist on the show. And when I explain it in normal English, they just pull out their theory and attach it to it and say this is what it is. I think that would be amazing to see because you know what I mean. How much can I trip that guy out? How much can I show him that's different than what he thinks? That's what I always thought. You know what I mean? Can I really show you something? As soon as I put that rod in the water, I'll blow your mind. I'll start making mud conductive. You start wondering things and they go, how did he know that he was going to get high voltage leaching? He said it like a month ago, and then now he shows it like it's nothing. How does he know that? Like, I mean, think about it. There's a lot of stuff that I tell you that you may think at the time, man, this old man's crazy. I'm not. I've seen it already happen. I know what's going to happen. Yeah, that would be a good set. Yeah. There's some people out there, man, and they probably challenge me pretty good on this. It, yeah. I think you're talking about the one with the sand. I think that's what John's talking about. Yeah, I think that would be something to test right there. Magnetic field with sand because you got the quartz in there, which does show, by the way. And I think Ken showed that when he showed the magnetics and stuff. He was showing that quartz itself has that magnetic side, and I found that to be true. So Ken Wheeler, I believe it is. He does all the magnetic stuff, and he's right. He's right most of the times. I'll tell you that. The guy's smart. Um, can you downsize the model line of components? Yes, you can. Do I think it's going to help? Probably not, but you can do it. You absolutely can do it. Um, Basically, all the weight in that is just the accumulation of metal. I mean, if you think about it, that's it. So if you get all threads that are smaller, if you go, something, yeah, like I said, different diameter than that, it takes off a little bit of weight. I don't know that you're going to get any of the plates any thinner. So if you make them in a smaller diameter, obviously you have certain things that you have to account for no matter what. The motors are always going to weigh what the motors weigh. Your wiring, you use thinner wire on it, and you get away with a little bit of that. The original invention used literally telephone wire. And when I say that, I don't mean the coax or anything like that, like modern day would connect it into your house. I literally mean old school 1980s telephone wire, where there's about 5 wires in there and it's white and blue, white and yellow, white and orange. You know what I mean? Exact ones. So, yeah. So, let's see. Can we get rid of the motor weight? And then you go, well, we're using PC fans. They don't weigh anything really. I mean, a little tiny bit. Can you go smaller than that? It's kind of hard to and get the same power out of it and have high voltage be able to sit next to it. I think that that might be a challenge. I've used DC motors, and some of them die on you as soon as you put the high voltage in there. You get a big enough one, it powers through it. Some add energy to what's going on because the disc picks up energy. You really have to match the parts at that point. Uh, you think the initial one was legit and the rest are all kind of whatever to make it going? Yeah, well, I'll be honest with you, man. Do you want to be known for anti-gravity? And I don't mean that in a bad way. I mean, if you do, hey, great. If you don't, and you live in a country that would put you in the brink for that, I don't know that you want to be known for it, but you also want to show the world that, but then you can't give them all the answers. I don't know, man. It's a toss up to me. I think some of them are faked. I won't lie to you on that. I think some of them are real. I think some you can't say that they're fake at all. It would take a lot, and you got to be standing right there in order to say one way or the other. But yeah, man, that's something different. I don't know if it's a Cat 7 cable. It's just old school telephone line. It's kind of like it's the thing's thickness is your doorbell wire. I think it's a 20 gauge, ultra thin coating on the outside. Like this stuff leaches energy all day long. So that's kind of what got me going there. I mean, I saw the plate, you know what I mean, put together and all these things coming out of it. And I said, let's look at the wire that he used and look at what the gauge it was versus the insulation. And that insulation was junk, man. It went right through that insulation, no problem. So kind of how I came up with where I'm at now versus, what I'm looking at. And like I say, I'm guilty of doing what everybody else did. I thought I knew better and I built it unlike his and I paid for it. So, yeah. The lean towards deceptive, I think the like a magician. You can also look at the physics say, well, do I see or yeah, dude, everybody could do it to make money. Okay. I mean, there's so many ways you could fool somebody on some of this stuff. I know this. if I lift it, I'll have people at my house the next day or within 2 days to look at it because it's a big thing in physics. And they would want to see that you did it and you did it properly, and then it can be replicated. So there's absolutely nothing in it for me to do it other than the right way. Whether it works or not, hey, that is what it is. There's zero in it for me for doing it the wrong way. So yeah. You remember watching those videos 10 years ago? Yeah. I only caught on to it God, what was it, 4 years ago? I think it was. Yeah. I didn't start building it really. Oh man, has it been 3 years? I think it has been 3 years that I started building it because I built like multiples of this thing. You were interested in the plastic girder on the bottom motor. Well, that's I had a picture of it, and I'll be honest with you, it's just a shell that houses the motor, and then you'll find like what I have right here, something that looks like this, except for their little white connectors, and that's what you'll find under it. There wasn't anything, no fans under there, no blower, no, I mean, no hot toddy. I mean, there was nothing under it. You know what I mean? It wasn't anything that everybody else speculated there would be. There wasn't anything there. It was just that. So, what's going on, Ricky? Nice. You didn't. I don't think he made much money. Like, to be honest with you, other than those couple things that went viral on that, he hasn't been doing much on there, man. I don't think that he did make a lot of money. He sent out some kits and he made some money off of those. But I mean, he even did live video chats with this thing lifted. So I can't tell you one way or the other, man. I know he put it out there as best he could. So directional energy beam. I can make one. I don't have to do the experiment. I can't show it on YouTube. Yeah. Showing directional energy weapons on YouTube is not a good idea. They tend to. I live between two Air Force bases. Doing something like that would actually be a very bad thing. So I don't know if it's illegal to do that, but I don't think it'd be a good thing either. I mean, I don't know. Honestly, I know I did it once and I walked away and I said, nope, it's been taken apart. So yeah, I don't. I could tell you right now, it's not terribly difficult. I mean, I'll say it because I don't think many people are going to put it together. If you have repetitive frequencies again and again and again and again, and you understand what's going on in a radar system, all you have to do is direct the energy in one direction based on the same physics that's going on there. And that's it. You have to create the resonance chamber in order to get the frequency to resonate again and again and again. And once you do, you can put out an energy weapon and use those waves in order to create, how do you want to say it? Disturbance in the aircraft, turbulence, whatever it is. It's basically going to make that thing resonate so that it's not going to be able to stay in the sky. None of the motors are going to work on anything, and it's going to go whoosh. Yeah. Yeah. Basically, that's what it is. So, and people get really sick around those kind of things, those directed energy things, because they play all kinds of havoc with your body. So, yeah, it was best just to, yeah, let's just put that one aside. We don't need to go there. There's no reason for it. But yeah, I mean, you can look it up yourself, man. It's not hard to make the calculation once you see exactly how these things work. It's also would be something good to understand if you said, okay, how did Roswell happen? And you go, whether you believe it's a UFO or not, it basically has to do with the invention of radar. Well, early in every system that they used a dish in, you couldn't stand in between the dish and the signal, right? Because it would take all the water out of your body. Well, it's kind of the same concept. You're messing with things and people. So then you'd go, oh, but if we tone that down and we do this adjustment here, then we can just make somebody sick. We could do this. It causes a frequency vibration in aluminum. So then we can shoot it at that. So it makes you think, what part of Roswell was correct? The getting it out of the sky? I think that part was correct. Were there little green men in it? I hope so. I mean, I'm kind of crossing my fingers. I'd like there to be. You know what I mean? It'd be fascinating, but do I really think that there is? I don't know. I'll tell you right now, give me a ride in that UFO, man, and I don't care how green you are, if you got big eyes or not, man, we're going for a ride. Okay? That's all we're worried about. It's yeah, well, there's another side of it. We're not going to talk about that, John. That's the basic understanding of it. Yeah. Uh Giant gravity flyer. Yeah. I don't know that we'll get there, but hopefully the understanding, if this thing lifts, I'll be honest with you, what's going to happen. If it lifts, we're going to find out why it lifts. Then we're going to build something even better based on the same answer it gave us. And then we'll have something way cooler that we can sit in, drive in, fly in. And I guarantee you what we're going to end up with is something with aluminum, bismuth, and aluminum on the outside. And it has to do with the same reason I told you how a transistor actually works. Okay. You see, most people don't understand this. When you compress the bismuth, it becomes lead. When you liquefy it, it's still in the crystal form. It has a low temperature. It's much lower than the aluminum. But in that casing, it's going to liquefy and then harden and liquefy and harden based on what you're doing. Now, as soon as you hit it with energy, it acts like a massive capacitor. Okay. It goes from a transistor to a capacitor. So that's the understanding you got to have of this. That's why I always say it's like a sandwich layer and it's going to liquefy and harden. And then based on what you're looking for is how you're going to get it. It's not always that you're looking for bismuth. You may need the property, of the lead itself, but it's not normal lead. So there's a lot in that, but that's where the study has to go from here. But you're taking like a non-conductor or a semiconductor and making it conductive in order to fill out the energy in the field in order to make that capacitor works. But then you have a spike that goes on in the energy in bismuth, which will actually make it a massive capacitor instead of just gaining a little bit like a normal transistor does. Because a normal transistor gives you a little bit extra energy because of the saturation rate. Then you're going to get a lot more out of the bismuth. So, yeah, there's more there. So, you think an El Camino would be the best craft? That would be hilarious. Oh my God, dude, you got to have the little dangly balls that come down. You know what I mean? Like on the windshield, you got to get a set of those if you make that a craft. Dude, you got to put the little Mexican blanket on the back of the seat. You know what I mean? You always got to have a lowrider in the tape deck somewhere. Yeah, always got to have it. That's right, John. We got it. Got to have a little lowrider going on there. Yeah. Car retrofit. Yeah, that'd be awesome. That's the way to go. Well, that's kind of the thing, isn't it? I mean, transistors, capacitor, electric, diode. What configuration is the metal in? We know the aluminum state. We don't know the bismuth state until you start hitting that thing with some energy, right? Then what happens? You get heat in there, you get cold in there, you get a transfer of energy. Is it in resonance? Is it not in resonance? Yeah. A lot more than we think. I like the car retrofit. Yeah. The The ranchero. There you go. Nice. Oh man. Nice. I love that. Give me a little bit of low rider. You gotta have some screaming Mexican music in there too, man. I come from California, that's why I say that, because that's always what I hear from them. You know what I mean? Like, yeah, 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 all the time. Gotta have it. Can't go without it. Got to make the front pop up a little bit. You know what I mean? Get yourself some rockin' tunes in there. You know what I mean? Yeah, you got to go full bore on that, man. You don't have hydraulics anymore. Now you got some kind of anti-gravity thing that gives it to you. Don't ever think they wouldn't do it, because they'd be like, dude, come on now. How can we not? Yeah. Harmony of energy. That's right. Well, so you can I can imagine two possibilities: vacuum being exactly a vacuum and containing energy, or a smart, or a system that deficient does beyond the 100%. If you get it up into the atmosphere, you're going to get over 100%. That's not the question. It's just the way it's going to build out because of the energy already there. You're going to have a harder time towards the surface of the planet than you will up in the atmosphere. You're going to be over unity in the atmosphere all the time in one of these UFO craft, that's for sure. That's just basic physics. That's electrical engineering. See, we use both. There you go. There's just a lot of high voltage up there, and it's in the form of potential. And all you can do is convert that potential over, and you're going to put it into the voltage that you want. You're going to drop it into a capacitor, let it mix, then you're going to, rectify it to whatever one you want. That's what you're going to do. That's not terribly difficult. I mean, that's kind of why we're looking at Wardenclyffe in the opposite direction than everybody else does, because we're not looking for the energy to flow out of it. We're pulling it in. And if you can understand that, going into a UFO craft makes it a whole lot easier. Nice. I told you they all work together. Depends on the capture energy to the point of the craft, the way you could part right next to the sun. And yeah, you definitely could. But think about it. If there's a scalar field between the sun and the earth, right? That means that there's a frequency in there, and that there's a way that you can pull that into some kind of a coil system or some kind of a transformer system if you can adjust the frequency of those systems. That means that you could literally tap that energy wherever you are. If you knew the numbers on everything, then man, you might be able to tap that right there and create like a third coil in the system, which is possible. I've done it in a scalar field and pull the energy. If you could do that, then kind of energy's everywhere. I mean, if you could think about it in that way. Wardenclyffe of both. Well, I can probably agree with that. If you, yeah, if you look at it that way, yeah. I'm just saying, in the way most people view that thing, they just saw it as a tower that blasts out energy. I see it as a tower in reverse. Okay. Could it do blowing out energy? Absolutely. I won't disagree with that one bit. You're absolutely right, limited state. It could do both. I just see it as the opposite side of what everybody else sees it, but you are correct in the conventional thinking of it, because it will do that. Yeah, different planets have different energy. That's a fact. There's no getting around that. That's a fact. Yeah, could be a difference in the energy there, yes. Outside reflected the core, yeah. You want to know how Joe's date went? I didn't ask him. I figured he'd be bragging to me if it went well, so I didn't want to get on the other side of that either. So hopefully it went well. Flipping the polarity, yeah. Well, see, now we're talking. I think there's energy everywhere. I think that's what people aren't seeing. So we have it in the scalar field, right? But is it empty in between? I don't think it is at all. I think that's where the energy is being, like, how do I say it? Just under the surface. Like, we don't know that it's there, but if you put up something that matched the frequencies, then you would find it. And we find that a lot in scalar fields. When we make it with 2 Tesla coils, you don't see that there's energy there until you put another coil in there and it picks up the energy just fine. And then it works as a relay station. While you're pulling out energy from it, it'll still work as long as you had a balanced system that had the same frequency. Let's see. 2D conditioner somewhere advanced, matching the way you can really advantage the tune effects after. Nice. Been quite a few weeks through watching your uploads. That more sometimes just more and more questions. Although maybe questions are it tells you, dude. I'll be honest with you. Ask me a question you want. I try to answer them the best I can. Sometimes, man, if the giant paragraphs takes me a while. Yeah, there's a lot of things in there that aren't in conventional science. I'll be honest with you. There's a lot of things that you would you need to see them, and a lot of electrical theory in there because I've done every high voltage thing that you can probably do. Um, with varying degrees of success, obviously. And there's still more to come. Sean and I were just talking about a propulsion system based on a Tesla coil. So really interesting the way it planned out. I don't want to say too much because I think you wanted to do it with me and we'll do it together. But really should be powerful. So yeah, nice. So yeah, I think honestly, I think we're worried too much about the power system. If we could figure out how to take that field in between the scalar fields, we had no problem getting power in our own solar system. Outside of it, who knows? You know what I mean? Not like any of us been there, so how do we know? But inside the solar system, if we were able to do more testing up there on this and this kind of theory instead of growing plants or something else, I think we'd get there. By the way, I was seeing the water smacker this weekend. I don't know if you guys seen that. It has to do with the same thing as a rod down the center of the Tesla coil. He said that they run that thing at 20 hertz. So, which is very interesting to me because we're always such high frequency on our Tesla coil. So it got me thinking, how do I get this Tesla coil to give me 20 hertz? Now it's a beat frequency, so you can always run them 2 Tesla coils and get a beat frequency out of it. That's one way. We could change the frequency going in if we think about this differently. Now, they don't use a Tesla coil in the circuit. They use from what I've seen the first time he was talking about, Bob Boyce it was one of those donuts like this, and it had multiple coils inside that transformer with a ferrite core. And then you basically take a frequency and put it in there, and then everything would get saturated with that frequency. That's the way he was doing it. So I think that might be one way. We don't necessarily need a Tesla coil if it produces the same result, right? But he did the same thing. He was resonating the inside and outside. The outside was aluminum, and the inside was a stainless steel rod that he put right down the center of it. And it should tell you something there. He was able to get the water that changed into negative energy, which we get with our Tesla coil with the rod down the center, okay? And then put it next to the thing of orange juice and get the thing to transfer the flavor. So I'm wondering if that frequency was a reason. Yeah, but a question on the Meg fact or real working plus give a simple answer. It's a fact that it works. You're not paying for the magnetic field. You're switching the field back and forth because of the magnet it's in their system. And all you're doing is adding electricity to it and frequency. And if your frequency matches the metal, you're amplifying the frequency in the metal just like a Tesla coil would. So you switch one side to the other, all like this, because you didn't have to pay for the amperage that goes into it. You get more energy out. That's pretty much the simplest answer I can give you. But yes, it works. As a matter of fact, we had Heliarch on here, And he was talking about the Meg twice. Um, man, we also had Tim Tron on here, and Tim Tron was talking about it a little bit, in the beginning, and another time I talked to him on a live, and we were having a conversation on it, and he absolutely knows what he's doing, and he shows it on his channel, by the way. And for those two guys, by the way, if you wanted to contact them one on their channel and get the information to build it, if you're in the middle of it or something and you wanted to complete your work, absolutely go on their Patreon and get their help. Costs a little bit of money, but man, it's so worth it. These guys have it. There's no question they have it. I could tell you based on what they're working on, they have it. And I've seen the system, and he's given accounts of the system that match exactly where I'm at and how things work. So yeah, those are the guys, man. Those are the guys that are just top notch on this thing. The other question: if the magnet is permanent current and the electrode is permanent voltage emitter, what if you use both at the same time? Well, see, that's what Jarvis talks about. He wants high voltage, high current, and he would have to use magnets in one and an electret in the other. It can't just be an electret and it can't just be magnetic. It'd have to be both. How that system configures, I don't know. That's not something that I dove into, but that is something that Jarvis talks about when he talks about his electrets. So, yeah. Now, is it possible in a DC system? And the answer is no. In an AC system, it is. An AC system, we see it all the time. You can raise the current in an AC system, no problem. In a DC system, it's based on the frequency, and you'll have to change the frequency, which will change the voltage in there. So that one's more like a combination lock to get done. But in AC systems, it doesn't care. You can add as much amperage to it with the voltage. So if you're doing it that way, you can get both, but not in a DC system. It doesn't work. Let's see. Nothing is permanent. Yes, they all have leakage. We know that. Unless you can create, that's one of the things about those things. An electret used aluminum around it in order to keep everything going to the same direction. If you can continue that field while still opening it up, it should stay charged because the charge is baked into it based on the K value of the actual electret. So you'll know that because you take it out of aluminum and it goes down in value, put it back in the aluminum, charge back up. But are you really charging anything? Did you add anything, any voltage, anything to it? No. You just realign the fields in it and it gave you charge again. So it should tell you the answer of what's going on there very easily. You're not necessarily charging it, you're just realigning the fields again, which is the same thing in a magnet. If you go and take your magnet and you put it on your screwdriver for a day, you're going to realign the fields inside the screwdriver. Then, after a while, the screwdriver is going to demagnetize, right? What do you have to do? Realign the fields in it. That's pretty simple. It's the same answer for both. You're just dealing one's in voltage, one's in the amperage field or magnetism. So, yeah. Solid state dynamo, pretty much. It's a solid state dynamo. There's also something that you could do called a bit. But yeah, pretty much a solid state dynamo. Bearden described it pretty perfectly when he said you didn't have to pay for the current. Now he gives you a bunch of extra terms in there that if you like that kind of stuff, you're all hee-haw about it. I don't personally care. It seemed real simple. And you see it in the temperature test that you do on these things. You'll see one side get cold, then the other one get hot. And it tells you which side the magnetic field's on. When it's cold, it's a voltage field. When it's hot, it's an amperage field, right? So it bounces back and forth, back and forth, back and forth, and resonates with each other. And that's pretty much what goes on. You're triggering something in one to create the pulse. Boom, it triggers. It goes to the other side and stops. Then it triggers and goes back. There's just a simple system that goes around in a circle. But yeah, you'll see when you get to the hot and cold test, it tells you the most things about it you want to know. Yeah, pretty much, man. you couldn't keep 0 point and anti-gravity. Let me explain things. It's all temperature. So I know this gets confusing. Okay, you just got to understand it. It's all temperature, and I say that not because the temperature is the factor that creates it. It's because the temperature is a side effect from creating it. It's where you see it. So when you do a negative energy circuit, which means that you're at room temperature or below on the electricity value, right? And the lower you can go on the electricity value versus the temperature, you're good. Okay. The colder you can get it under room temperature, does that mean you can go blast this thing with an iceberg or something? You know what I mean? Or whatever you want to, use on it? No, that doesn't mean that at all. It means that it's changing the temperature in the room based on the circuit itself. As it changes temperature, it's drawing in the heat. As it draws in the heat to it, as it goes through and flows on the outside, there's a heat bubble forming. When it forms out there, you're going to get a higher amperage, which means you're changing the value in your circuit. You're changing the cold to go faster. You're carrying a little bit of amperage on the outside, and it's a temperature differential between the two. So you get to end up with a room temperature superconductor, is what you end up with. But it's the understanding of pulling the voltage through the whole thing. It's the same thing as a PNP. Okay. You got to start understanding it in the same way. You're pulling the energy through it. You're pushing the amperage through it. And conventional circuits push amperage, and the PNP and stuff pull voltage. And it does it by creating a draw. So you put a light bulb on there, it sees the heat, it's cold, it wants to go towards the heat. As soon as it hits the heat, boom. You know what I mean? You're getting it pulled through even faster. And that's also why you could take transistors and switch them, or take MOSFETs and do it, is because of that. You can hide the resistor by putting a neon light in there for that same reason. It's a draw, and that's all you need. Now, you think of a resistor in a PNP circuit, it's a draw, it's a heat. DC systems are really easy to understand. It's lowering the frequency in order to create more heat, which is more amperage in your system, in order for it to trigger the actual voltage differential it needs in order to complete the circuit. That's fairly simple, but the thing that most people don't understand is the hot and cold aspect to it. Once you do that, then hey, screw the resistor. Why would I want that? I just want a neon light. Why? Because the neon light will give you hysteresis and blow it out of the light bulb instead of putting it back in your circuit. That's why. It'll allow the voltage to flow, but blow out the heat out of the light bulb. Does it mean that there's a loss in there? Yeah. But does it mean it's going to heat your circuit up and ruin your system? No. That's the key right there. Your system is going to stay getting colder and colder and colder because you're not re-adding the heat. That's why. That's why the heat comes out in the light bulb. That's pretty simple. Yeah. It's a different understanding. And if you can understand transistors that way, you'll be way further ahead than most people. So, and you have to go back to the old school black and white videos when they tell you how it was made. And then it starts to make a lot of sense, because then you get into multiple things like the 555 timer, and then you get into the first chip that came out and how they work. And then you start to understand exactly how these big chips are working they're running your computer. There's a whole thing that goes on there, and it's based on the whole transistor process. And if you can understand it in the right way, then yeah, I mean, you're going to be golden. I mean, you're going to be able to do what you want in the system. You're not going to be held back by the parameters that they put on you in school. Heck no. I'm not. I never have been. I've been doing this stuff, man, since I was 8 years old. Okay. I've been doing the solder pot and everything, making connectors, putting up back shelves for my mom for her, company that does wires, and I, make some money as a kid. I've been doing this for a long time, man. Long, long time. And there's tricks everywhere. Oh, let's see. Let's see what this one is. With an orange on the top and the zinc plate, you will transfer the essence of the orange into the water. Ooh, that sounds pretty cool. So orange on the top, zinc plate, okay? You could transform the essence of the orange. I take it there's just a cup of water on the bottom. Now, do you have to put it in negative energy to do that first? Because that was my understanding. And negative energy puts a field out, whether it's in there or not, that you see it until it dissipates. So it pulls and spirals. So same but different. Interesting. Zinc is paramagnetic. He said yes. Okay, so the water's underneath it. Okay. Yeah, negative energy. I can see that. That's pretty cool though. You know how I like to play with all the food and do energy with it. So yeah, that's pretty cool. Gans field. It's a Gans field. Nice. Let's see. I have a single bowl. Just might do the same test and charge. Yeah, that'd be cool. Absolutely, show it. Question. Okay. Why don't you dig or talk to more about the Meg? Uh, I'll be honest with you, man. I talked to the right people about it. I do have transformers here that I'd like to get to. I got a whole box of them. I think I got like 20 of them. I got for free. So that is one thing in the future. Lately, it has not been a something I've been able to do. My wife's grandma passed. I've been having some health problems. Kind of just sticking to what I have and hanging on there. I'll be very honest with you. But it would be something that I would like to do in the future. I'll say that, but I would probably have to team up with somebody to do it. Let's see. 9 toroidal coils stacked in piezoelectric cylinder wrapped with one wire. Let's see. Varied rod or tube inside that. Laser through the middle. So what would the laser be doing in that circuit? I'm interested. So piezoelectric cylinder, which basically means just like what, like a quartz tube? Okay. And the wire varied, rod tube. So you think you're going to get a difference in what they actually do in the field? And laser through the middle. Not sure exactly where you're going. That's all in all about ambient field energy harvesting and propulsion for layman. Let's see. Yeah, the plasma gains thing, potential difference in the zinc also reacts to the orange. Okay, that's about the orange. Bells is changing systems community use. Nice. Do I have what I have is, oh man, a transformer like this, like everybody does. Okay, just a shell on the outside. And it's only about, say, this thick. And it matches the T-type that they were talking about on their channel with Timtron, and he made one. So you make a T out of one of them, right? And that's pretty much how it comes down. You put 2 magnets on the bottom. You have the sides that come into it, right? And then you're able to put the wire on both sides. So you have your magnetic value in there in both those. I have that. It would take some time, probably about a day. Grind it, flatten it, sand it with a belt sander to get it right, or a flat sanding wheel in order for it to be perfectly tight. Yeah, I do have that material in there. And I do constantly have wire running around here. Well, you can see all the coils over my shoulder. There's a lot more back there. So, and that's not all of them. So yeah, I do have quite a bit of stuff here. I have wire here and thicker wire that I build the coil wire out of and stuff like that. So, oh, laser carries the frequency out. Okay, nice. The null points in a single wire is what you should be focused on. Okay. Interesting. You heard about Ice Cube? No, I saw him doing commercials. Unless you're talking about something else. And let's talk about Bernie's Ice Cube. I saw that. Oh, if you're making propulsion energy through the laser point to point. Okay. I think there's easier ways to make propulsion than that. Let's see. Nice. Except what's inside the unadulterated orange and never touches the water. Nice. Yeah, I like that whole water smacker thing they were talking about. I just wish they weren't like $500. Um, how long does the orange sit in the zinc plate? I imagine you have to sit for the whole day, huh? Well, let's see. Question: have you seen Iron Man movie from Marvel? Of course I have. See, we all know the old man gets out there and does this stuff, man. I watch all the Marvel movies. Totally into that stuff. I'm gonna go watch Superman with my son here as soon as it comes out. Yeah, I watch all of them. I've even watched the offshoot Spider-Man movies, though I don't think that they were that great. What was it? No Damned's Web or whatever it was called. Interesting, some parts of it, other parts not so good. But yeah, I watch all that stuff, man. So all my kids watch it too. Your Water Smacker Pro just came today. You just got it, huh? Man, do some experiments and then send them to us. That'd be awesome. Set overnight, maybe. Okay. Try accompanies the gravity at a null point. Okay. We could try that. Interesting. Let's see. Ever heard of the Temple tornado? Blue Book High Strangeness Case 10270. No, I have not. I have not heard that one. Do I remember the arc reactor? I seen somebody say it's supposed to be. Oh my god! I've seen so many things on this. They okay. I keep seeing stuff that's supposed to be like atomic energy or over unity energy, and all they make is a little purple field on the inside and a magnetic field holding it in. I see a lot of that. I see spark gaps in a vacuum chamber, and they try to tell me it's something else. I can clearly tell you see that stuff a mile away. If you've done the experiment, you can see stuff a mile away. You may get a little extra energy out of a vacuum chamber, but you're not calculating the amount of energy that you're pushing into it constantly. That's the problem. Is a lot of these physics formulas do not look at is it a closed loop system, and they always say closed loop, right? But then at the same breath, they turn around and tell you, uh, we don't believe it does that. No, no, it just can't keep going. That's impossible, right? And perpetual motion, right? They tell you is impossible. But then they tell you about a closed loop system. So the actual physics answer there is in a perpetual motion machine where no factors will change whatsoever, that you can change the energy as you will inside the system with zero loss. That's it. That's the actual answer there. But they don't want to say perpetual motion. They say, no, that's wrong. Or, oh, yes, it is a closed system. Well, it's open to the other end where you're plugged it into your wall. You go, well, okay, we'll use a battery then. Well, your battery goes dead after a while. So where's your perfect system? Not until you get perpetual motion, you're not going to get it. That means closed loop. 100% works on its own, needs nothing else. Closed loop. Putting it in from your wall is not a closed loop. That's open. Because why? Because you can pump as much energy as you want into it, and it doesn't matter. Okay? It ruins every test. So as soon as you get it out and say, okay, I want to go run this, and you can put it on a battery, and go, well, my battery dies after an hour or two. Well, yeah, no kidding, huh? Yeah, we saw that one coming a mile away. Right on, brother. I see you out there, Tim, watching some stuff, man. Thank you. LF4 Scalar meter. Interesting. I got to get one. I don't have one. Nice. Let's see. Big recommend you check out the 10270 and its military men flying Van de Graaff powered vehicle. Well, of course, it has static electricity in it. I've said it before. You ionize the air, static electricity, and you also have a radiant field. With those things, you could build basically any UFO you want to. Then you just got to worry about propulsion system, because at that point you're building a field bubble. That's should be known physics, but it's not. Project Blue Book, yeah. I like the one that looks like the two pyramids, one stacked on top of the other. I like that one. I saw that one in the Project Blue Book. Let's say uses magnets is magnetized. It can be used for decades. There's enough energy to magnetize the magnet like 50 times, right? I don't know about the longevity of it. I know that it works, and that's about all I could tell you about it. It works and it flows a certain direction. That's it. I don't know how long the magnets will last. I don't know that they're charging the magnets at all, so I would imagine they dissipate like anything else, but they stay in a magnetic field. That's for sure. And if you've ever seen the demonstration they did on the MiG, by the way, because there was one, what they're showing you is how the field flips. So the guy turns it on, right? And he shows you both sides on this magnet, both sides of this transformer are on there, right? When he flips the field once, this side becomes weak, this side becomes incredibly strong. He flips it again, this side becomes incredibly strong, and this side becomes weak. He's showing you that you're shifting the magnetism between the two. Tesla bifilar coil inside the gravity flyer room disc. I did try a bifilar coil and they're way too much. And you don't need them. Bifilar coils are basically capacitors in themselves when you put them together like this. When you put a plate in between, you have a collection plate in between. Between the two rotating plates, it does the same effect. It's kind of redundant, to be honest with you. Though it was a good idea. I did try it. Okay, because I wanted to see if I couldn't get those magnets to pop down, and I could never do it. Full. Okay. Sorry, I'm kind of getting around all this. If they got it, we can remake it. I 100% agree with that. We just have to learn the fundamentals of what they're doing and not what everybody says they're doing. I think that's one of the biggest misconceptions. I learned that on the gravity flyer right away. You're not doing what physics tells you you're doing. You're doing what the inventor created for you to do, and you have to follow that. Do what Gorbachev did for propulsion, but go get a bunch of shells. That'd be awesome. What's going on, Papa Bear? Oh man. Rodent coil as top load for Tesla coil overlap the scalar. Well, I think you could put it up there. I don't know that you're going to get the result you want. The rodent coil will immediately heat. As soon as you attach it to the number 2 winding, it won't be like a plate that dissipates some of the heat. It immediately takes the heat and it starts setting the plastic and melting it. That's what I've seen. Thank you very much, man. I appreciate that. 8,000, man. Getting lucky is what I am. Nice. Uh, Let's see. Surprising it's so simple. Fact. um. Yes, it's a plasma condenser. Okay. Is all right. Examine the stuff top. Looks like the three black magnets and the magnets dielectric and the coil stacked. Interesting. Mm. Yeah, it's kind of interesting how some of these things are put together. My gravity flyer is put together based on the way that the actual planet is, and the fact that it has a rotating magnetic field in the center, and then on the outside it has a high voltage field. I mean, there's no coincidence there. It also has a radiant field in order to hold it in. I mean, the guy built it based on the actual Earth itself. I mean, which is probably makes a lot of sense, to be very honest with you, with what it's getting. So yeah, interesting facts, man. Like I said, that electrical universe, man, needs physics, and the physics needs the electrical universe because they're intertwined. There's no question about that. It just are. I mean, and then, oh, let's get into string theory. He always says it's a musical thing. Well, we talk about that all the time in harmonics and stuff. That ties in right into the other two. I don't know why they can't see it. When you resonate a coil, you're basically creating a harmonic in the coil. When you go on to a second coil, you're creating a second harmonic. Then you get on to the next one, the next one. Look, you're creating multiple things in there. Now, can you change them just a little bit to have a little variance? Yeah, you can, and they'll still work. There's a perimeter that goes to where it's still a workable signal that goes in all of them. The resonance and all that goes right in line with everything. And then when you understand it as a tornado, as you build out, you know what I mean? Just like your Russell scale, man, it makes a lot more sense, right? And then when you get to the thunderstorm generator and you're breaking things apart and putting them back together, then it starts to make even more sense. So, and you're doing that based on the resonance of the two spheres, right? One resonates the other. So you're breaking apart something, but you first had to use high voltage to ionize it. That system is basically telling you some part of string theory, it's telling you electrical theory, and then it's telling you basic physics on how things go together. How they can't see that, I don't know. It's all there. It all falls in line. It, I mean, you got to have all three to make the machine work. I guess it's people that see the answer versus people that pontificate about it. I mean, look, build it and see what it's doing. That's what it's doing. It's like the water car, right? Well, do you split the water in the chamber or do you do it in the piston chamber? Well, we all think that oh, he built it and he created this thing. He had gas in there and then he put it into a tank, or he immediately put the gas into the carburetor or into the intake. And that's how he got it. But really, all the energy comes from splitting the water inside the cylinder. So it's the explosive value. It's much like a diesel engine in that way. I mean, think about it. We could throw oil into the diesel engine. The only thing you got to change on it, you know what I mean, from running your French fry oil to diesel fuel, is the temperature of the injector so that it doesn't never clog up. But that's basically what you're doing. I mean, you could make your car smell like French fries. We had a guy in high school that did that. He just went over to the McDonald's, asked him for the old oil, and they gave it to him. And his little Volkswagen smelled like French fries everywhere, man. It was like you went by getting hungry, thinking about McDonald's is what you did. But it was a simple understanding of combustion in the chamber versus non-combustion in the chamber. You know what I mean? Or a light combustion in the chamber. Diesel takes a heck of a lot of combustion to do, but it's the splitting of it right then and there that does it. So water in the chamber would be the same thing. BMW right now has come out with an engine where they put water in the cylinder right there and they split it in order to get another 20 horsepower. Whose technology do you really think they're using? Interesting. Yeah, they use the water cars understanding to do that. Let's not kid ourselves, okay? Uh Nitrogen and lasers, two things I don't like playing with. Let's see. Stan Myers. That's right. And it was stolen from him. You're absolutely right. Yeah. Basically. I mean, there's videos out there, guys, that I've seen. Some on Gerald's channel where he has a Stan Myers video. And I think it has a reporter on the front, some gal. And instead of Stan Myers himself, but nonetheless, on that video, he tells you how he does it in the combustion chamber of the actual engine instead of outside of it. I mean, think about it. We all know how to put it on the outside of it, but in the combustion chamber, that's what he was doing. That's why they get so upset because there's no tank to it. There's no fueling. There's nothing like that. It's an automatic done. You just put water in it. They just, you know what I mean? I don't know. Maybe they just didn't charge enough water at the gas station. You know what I mean? Because we all know what's going to happen. They're not going to let you get away with a water car. You're literally not going to be able to take water out of the ocean. Not going to be able to take it out of the lake. If you use it from your sink, they're going to start telling you all the stuff that's in your sink water that you can't use it for, right? Then what are they going to do? They're going to put up gas stations that are filled with water, and you have to go over and buy their water. That's what these people do. I mean, they're the biggest snakes in the grass ever. They'll try anything. I mean, they'll literally put like what was that? Blazing Saddles. They put that toll in the middle of the big empty field, right? There's nothing around them for miles, and there's a toll bridge right there. Yeah, that's these people. That's what they do. They make you stop for a toll in the middle of nowhere in order to pay it. Oh, nice. There was a story about some sci-fi stuff, even time travel stuff. Nice. Oh, please answer your question. I'm trying to look. Question. What do you think about this shooting nitrogen laser or DVD laser to a component or non-compressed plasma or Jacob's ladder? I don't mess with lasers a whole lot. They're just compressed light. And I know some people lifted things off the ground with lasers, but I've never messed with them. So I'm probably the wrong person to ask about that. Oh, let's see. Yeah, they do want to sell you everything. Gee, that was the most hilarious moment, by the way, of that whole movie. It didn't have any bad stuff in it as far as the racial stuff at that point in the movie. It was just literally, dude. It was a toll bridge. Literally, they have that little gate that opens like this, right? And charge them a dime to go through it, and it's in the middle of nowhere, man. That absolutely hilarious. Oh, let's see. That's Jeremiah test the laser and Jacob's. Okay, yeah, I hadn't seen that one. I will tell you this: I seen Jeremiah do let's say a bipolar Tesla coil, not a Tesla coil, bipolar coil. Okay, from Tesla, but he built it the same way Tesla did it, wires side by side, not one on top of each other. And he had this magnet that was rotating, and it was going all around. Man, it was a video short, dude. It was awesome, totally awesome. I saw that, man. Let me see. You know what? I'll see if I can't find it here because that one was pretty cool. Let's see. Hopefully he won't mind. Oh,
So here's one of those magnets spinning around. They look like this when they're not moving. And once they do get moving, they like to pick a nice stable orbit right about 3/4 of the total diameter of any of these bifilers. Doesn't matter which one it's placed over.
look at that, man. That's amazing. They're floating right up there. Hmm. Anyway. Let me I'll put that here in the chat in case you guys want to go back and watch that. I just thought it was interesting. Yeah, I think he said AC is what he runs on his coil in order to get an anti-gravity thing. So I could be wrong, but that could very well be. And again, I'm not sure. Interesting though, really cool experiment. I looked at it and go, man, now there's a good reason to build those things, man. We can do something like that. Yeah, it would be really nice, man. Excuse me. There was a video a real long time ago using a spinner setup and resonance between the separate spinner around it. Ooh, that'd be nice. Yeah, if they had some kind of remember those old spinner things, man, where they were all just like a V on the bottom, top, I guess is what you call them. You just as a kid you used to spin them. Yeah, that'd be cool if you put some magnets in there just like that, and then put it on one of these coils and have it. That'd look pretty rad. I'm into that. Nice, yeah. That'd be awesome, man. Let me see. Hold on. Well, it takes me some time, man. I'm always kind of busy. Give me a second. Why can't time anomalies exist? Why can't time anomalies exist? Plasma in the same black hole, kind of laser pulse of plasma, speed of light. I don't know that time anomalies don't exist, to be honest with you. I think they exist a lot. We don't recognize them because we're looking at linear time instead of what time actually is. I think you change that understanding and change it. Now, everybody talks about their space time and their black holes. Good luck. We all don't know anything about a black hole until we're standing in front of it. I don't think we would, to be very honest with you. We can measure certain things out of it. I don't think that we're going to get the full understanding of what it is. But whatever. Space time, black holes, have fun with it. Not really the thing. I deal with mostly time dilation because it's a phenomenon you can actually put something to, and you know things about it because you see it happen. Space time, have fun. Oh, let's see. I did. Near the black hole, would time change? Probably, if there's a big enough gravitational field, being that time is based on the energy level. And then, yeah, it would change. Absolutely. You'd have time dilation over by the black hole. That I have no problem with. But yeah, you would have it there. Let's see. Time is energy, man. I mean, I don't know how to tell you that, but if you're creating time dilation, you have to use energy fields to do it. And so time is basically energy. It would be F equals I over T instead of F equals 1 over T. It'd be the frequency equals the energy over time. And that's pretty much how I see it because that's how time dilation works. So I think that's not a 1. I think it's an I, to be very honest with you. You uploaded a short? Okay, let's take a look. Hold on. Just second, Dennis. This is the latest one that I've seen. Yeah, it looks like it's hot. It looks like you're getting a beat frequency with the lights, though, on the top. The ones in your hand. I don't. It doesn't look like the right frequency. But then the light looks like it has that same frequency to it. I wonder. What is that red stuff in there, by the way? Let's see. I'll move my head so you. Oh, nice. That fish got his he got his thing got sparks. He's got it working. Sorry, that's my fault. The resistor fell out. My bad. Got it fixed, and now he's got his coil up and working, man. I expect to see a lot of quartz or stones or crystal videos coming out of that coil. Just remember to turn it off every time you set something down the center and turn it back on so it can adjust to the resonance of it and then you don't blow up the circuit. Oh man, the question about light and stuff like that, to be honest with you, I don't play with lasers. So I wouldn't know. I'm probably the wrong person to ask about that. Yeah, the rod tapped at the bottom of the coil. Nice. I've done that myself. It's sometimes easier. You didn't think it was working, but I hooked it up in more voltage, and now it is working. Nice. Hey, make sure you keep the PMC circuit as far away from the coil as you can, or else it'll form an anomaly in your power system, and it'll look like it's not working, and then it'll jump super high. Okay, and that's not what you want. So make sure that sucker keeps a fire distance away, so that as you turn it up and raise the amount of energy in it, it'll build properly. Can a laser or light push plasma? Sound can. So anybody out there see the levitation experiments with those little balls? So basically, if you take the speakers like they have in that situation right there and you put a spark gap in between it, the plasma itself will move. You'll move the entire spark gap in the plasma based on the frequency of it. It'll just move it. And you'll see it, jump here, there. And then if you have it on the outside, it'll push away from it. You know what I mean? Yeah, it'll absolutely do that. It's one of the more interesting things that goes on. So it kind of tells you a little bit about how fields work on the earth, doesn't it? If you have this plasma layer, then you get the layers in between it. Some are plasma layers, some are air layers, some are plasma layers. So it absolutely does work the same way. Sound is not fast enough. Oh, it is. Oh, it is. There's actually tests out there that prove it. And if I knew exactly where it was right now, I'll pull it up for you. But it absolutely does work. Matter of fact, I think Charlie C did it, and I believe I watched, if I'm not mistaken, the alien scientist had a guest on probably a year or two ago, and he showed it on there as well. It actually works. So, let's see. I saw a video last night on quartz crystal with Tesla coil and glass bubble. I think if it was a vacuum or not. Interesting. When you try that one wire experiment, man, I want to see the crystal in water and see what it does. I've seen a lot of people tell you how to charge a crystal and they don't put it in water. And yeah, it doesn't quite charge your crystal. Just say that. Nice. Core Castle, yeah. Dude, by the way, oh man. Trying to think of it. Joe would know it. There's a guy out there that did one on the Coral Castle, and oh my God, was it so good. Mysteries of the something. I don't remember the guy's channel right offhand, but he did an excellent job on it. Man, I wish Joe was here to tell me. But yeah, that guy, awesome work on that. He has a bunch of videos like that, and he goes super in depth on everything. So if you guys know what it is, throw it up, and I'll put it up on screen. You got your Tesla coil working. Awesome, man. What was it? What was the problem? So cool. Let's see. Tongo explosion. Yes, it was sound travel super fast. Yeah. I'll be honest with you, man. I'm not trying to do anything. I'm just telling you an absolute fact that I've seen it and a lot of people have seen it, that it does move the plasma. Let's see. Let's see. I'm going to build a stand for a crystal so that I can heat it up going orange if possible. Try it in the water, man. Just remember the field flips. And if you can get I want to say this. If you can get the piezoelectricity activated in there, then yeah, it should start to heat up, but you're not going to get it until you get it to oscillate. So I want to say this. If Mike did this experiment once and he took a piezo disc and he hooked it to a frequency generator and he put it right on the side of crystal and he was able to resonate the crystal where it started jumping all over the place. Kind of like the monks did when they started playing the horns and you heard about the rock going every which way. This is what happened to him. So he was saying that you have to find the frequency that it resonates at with the piezo disc on the side of it attached. And then it would start to put out the energy that you wanted to, because you're tapping it, faster than you think you are. Like you can get it up to 25 megahertz. And yes, I know if they say piezo disc can't do that, I can tell you that's not true. They do that. And you can start to resonate this thing. Maybe it does it at low hertz, maybe it does it at high hertz, maybe it does a low frequency. You know what I mean? Just have to find out. But Mike said that works. So yeah, they make stuff float with sound. They absolutely can do that. Let's see. Violation or vibration. You have to do it with vibration, but you have to do it with resonance. You need it to be super fast. So that's just kind of curious about it because I think quartz may work on a beat frequency, so it may be really low. I mean, look, when they talk about the energy in the earth and they tell you there's a really low hertz, that's the beat frequency. When they tell you it's a raw high amount of frequency going on, that's what you get from the surface of the planet till you get up to the atmosphere in the planet. You get a high frequency there, but in the earth itself, you get a low frequency because it's a beat frequency. So yeah, it's a little bit different. And it has to do with the stuff it has to travel through. You know what I mean? They're not getting open air, so it doesn't get to go super fast. It has to travel through things, so it slows it down. So it comes out as a beat. So let's see, puts the crystal in parallel plate capacitor and connect the spectrum analyzer to it to find its frequency. There you go. That's a good suggestion right there. Now, this is something that we should all know. The reason I keep telling you to put the rod down the center and put it into the water and then put the crystal in there is because it's negative energy. I know if you do the water smacker and you research it, you probably already know this. Bedini, negative energy spike, all of it. Well, it's kind of what's going on in your crystal. So putting it in water gets the water to be able to go everywhere in your crystal. If you do it with granite, works even better because the granite holds in the water. And then you run the frequency in it, man. That's the way to do it. By the way, uh, sorry, I just want to say an EDM machine. Okay, I think I got the letters right. Basically works on the principle of taking a piece of metal and electrifying the piece of metal, and then you take this little rod that comes down with some water in it, and you're electrifying each little point in order to make this really straight line, right? Well, when you do that, what do you need to do if you're going to do it to granite? Well, you need to put energy in the granite, right? And you say, well, there's not enough. There's not enough piece of electricity going on there. It's compressed in there, but it's not giving me enough. Negative energy gives it to you. When you put the rod down the center and you put it in the water, now the granite becomes conductive all over it with that energy inside of it because the water sucks into the granite and the energy is compressed inside there. Now hit it with the electricity with that same rod. You're going to get a different result. How is this how they cut all the granite in Egypt? Who knows? But it is an interesting fact that goes on with it. If you look at the machine, but you understand how negative energy works in quartz itself, then you really got something going on. Sorry. If you in granite itself, sorry, not quartz. Your frequency is 176 hertz on the coil. Wow, that's low. How did you get to 100? Not kilohertz? How did you get it that low? That's fascinating. Can you have proof? Okay. God, let me think of where I put it because I put it back in all of my drives. Let me see. Just give me 1 second and I'll see if I can't pull it up. Oh, let's see. It'd be in my liked videos. Oh man, this didn't take a few minutes, guys. I got thousands of these in here. How do I look this up? Sorry, guys, a lot of dead air. It takes a while to look this stuff up. And of course, they don't show it to you right away. I'll tell you what, man. Here's what I'll do. I'll find the video and I'll send you a link to it, and then you'll have it because it's absolutely true that it works. Oh, let's see. Let's see if it's under Charlie C stuff, and I don't see it right here. Okay, yeah, I'll have to look it up and get it to you. I do have it though. Oh, let's see. Sorry about that, guys. Yeah, I'll look it up for you. All right, we'll move on to something else for right now. But I can tell you it's on the Alien Sciences channel several years ago, and he had a guest that showed it. I believe, I don't know if Charlie C showed it or not. I did see it independently corroborated by another person on the internet, though, and I did save the video on my like list. So I will pull that for you. But it absolutely works that way. Let's see. We'll also make rock malleable. Interesting. I know that heat does that. You don't know the Alien Sciences channel? I'll share his channel. Like I said, you're going to have to look in the depths of his channel, which he has a ton of videos. So I will link you for sure when I find it on there. There's Alien Science's channel. One of his guests a long time ago pulled it up. So right on, brother. So there you go. There's Alien Science's channel right there. Yeah, Jeremy rocks, brother. He does. I watch that show quite a bit. Let's see. Right on, man. Yeah, it was kind of cool because they took the two things of sound like this, and they put a spark in between it, man, and it was actually moving it. And then also the there's another channel. God, what was it? It's a red emblem. It looks like a head, and then it has what looks like an atom on in the inside of it. The guy's got like 1 million subscribers, and he was doing that same thing to a Tesla coil with the plasma. So yeah, he was doing the sound in order to do that as well. I can't remember his name. Man, I'm bad at names, but he was doing that as well. I was just watching that last week. So yeah, sorry about that. Yeah, there's quite a few people that have done it actually. And I don't think it's whether the light is faster than the sound or the sound is faster than the light. I think would probably be a misunderstanding. It's the frequency of the light. It's moving the frequency of the light. I don't think it's about light speed at all. It's the frequency, and I know that frequency equals 1/time, so it's the distance between is the frequency. I fully understand that, but you're talking about like what was it, a kilohertz frequency? Because light itself at light speed is different than light to make it. You know that, right? At least I hope you do. That light speed is a total different calculation than actual producing light. They come at different frequencies. You can do it in plasma all day long based on the frequency. And it's not a whole lot of high frequencies to change it. As you change the frequency in, like, say, a DC flyback from a ZVS, and you can change the frequency in that, you'll change the color of the light that comes out in the plasma. That is a different calculation than light speed itself. So, well, that's what I'm trying to say. If you're in light speed, it's much different than it is for the calculation of plasma with light in it. I don't know if that makes sense to you, but they're two different things altogether. Got it. Okay. Let's see. If you turn a laser, then adjust the brightness. How fast does the brightness adjust, move through the beam? Like I said, I don't play with lasers a whole lot. You're asking the wrong guy here. Dude, my eyes got burnt from a welder several times, and I don't play with anything that has to do with light in that manner. Yeah. So, yeah. Okay. Depends on the circuit really well. I could tell you hit the same colors at the same frequency. That's for sure. I've done that. And look, white, yellow, purple, pink. I've got, what is it? I didn't hit aquamarine. I didn't hit blue. Violet, I did get. Let's see. I think that's it. I get blue if, how do I say this? If it's really cold outside and I use the rod down the center, I can get blue plasma to come off the wire itself. And I think that's the temperature differential, changing it from a purple to a blue. And that's the thing I think is going on there. But, there's a lot of different colors that come out of plasma. It's the same question that I'm asking. I don't know that it is. What was the? I don't think that you're changing the frequency. You're changing the amount of energy to it. The frequency has to stay relatively within a framework in order to get that light to be the same color. There's a, you know, one side to the other in that scale, yes, but it's the amount of energy mostly. Oh, I think he's talking about the pulses that are going on in his short video that he showed with the crystal. Hmm. Oh yeah, gases. Yeah, gases will show that field real well. Like you said, I'm not a real big laser guy, so probably asking the wrong guy here. Never ever try tuning one of your excellent build coils with a small short nitrogen gas in a primary soft copper tube of welding. Love to try this. Interesting. You know, I haven't tried to resonate with gas at all, to be very honest with you. That would be interesting. Hmm. In a primary of copper tube. So you're saying that the number one coil, to put it inside there and try to resonate it with the glass. Well, that would be really interesting. But then how do you see it? I mean, at some point, do you have opening or something? Because in order to see the gas, to see the reaction that goes on, you'd have to need something. Argo gas makes purple light. Nice. Oh, let's see. So gas is vibrating light. Lasers are light. Yes. Okay. So what pushes plasma fastest? Um, I don't know. I never really looked at it. I've only built plasma. I never tried to make it go in a speed thing. I have no way to calculate it. I don't have the equipment to find out that answer for you. So I honestly don't know. Hmm. Let's see. Neons fire off frequency underground transformer with no detectable current. Well, yeah, because the voltage. Most gases, when you remove the amperage in there, that's when you get the effect. It's the lack of amperage that gives you the effect in every gas. And that's why when you make a benchtop laser, okay, and you put the two rods there, and then you put the DC flyback to it, and in between those two, it makes the energy in there, and it creates the laser, and it shoots off across the room. Well, that's why that works. You know what I mean? Because it's high frequency electricity that's making that thing work, which makes the laser, not the amperage. The amperage is it's a holdback. It's what stops it from working. Yeah, you don't want any kind of amperage in there if you can. I mean, obviously you're gonna have some of it, right? But you're really amplifying the voltage field in order to get it. I mean, it kind of tells you something. You have a voltage field up in the sky. You have gases that accumulate in certain layers, and then the time it takes you to get through them is what gives you your color. So, yeah. There are full current lasers. I've never seen one. Hmm. Sure, they came up with all kind of stuff. I've never seen a current laser. I've seen current plasma. That I've seen. You drop your oils in the chat. I don't have any of that stuff enabled because I don't know how it works. Sorry about that. I'll have to ask Bernie how it works. I have no idea. All depends on what you're building. Build and destroy things. LOL. Like the military. I don't build anything for the military, that's for sure. You think all lasers are current? Well, I don't think so. I've seen lasers that work on voltage. Amplified photons. Yeah. Way out of my league here, guys. Again, I don't play with lasers or lights in that way. Let's see. Yeah. I don't know either, man. Without potential difference, that current can't go anywhere. A laser light is laser light plasma. Well, I'll be honest with you, man. I've seen it's just light. I mean, could it be plasma if you thicken it up a little bit? Sure. Is it basically just light? Yeah. And all it's doing is amplifying the field so you can see the light. That's basically what it is. The field's already there. You're just amplifying enough to see the light. Is what I've seen. What is plasma? It's just a state of matter. It is literally a state of matter, as far as I could tell. Every time that I've seen plasma, that's what it's been. And it doesn't have to be lit up either. It could be there and you just not see it. You don't really realize it's there. Like I said, between two scalar fields, there's probably plasma there. So, yeah. You say plasma is like magnetic flux? Yeah. I mean, I can see that. The heavier the magnetism that is that goes out in a high voltage field, the more plasma it creates, and the thicker it is. Yeah, I can see that. Plasma is any medium with electrical current running through it. Yeah, that's pretty much what's being said apparently through everybody here. It allows the matter to know which state of matter. Plasma, more than a state of matter, allows other matter to know the state of my matter. Okay. I kind of a little lost on that, but sure. Plasma is a reaction, but plasma is everywhere. So it's a reaction to everything going on. And I'm sure somebody's going to disagree with that, but just let me explain. In the center of everything in the cosmos, you're creating a time field, which is energy, which means plasma is present throughout the whole thing. It's the whole reason for the fabric of the entire universe. Okay. It just is. And it's basically telling you between two scalar fields in the middle is plasma, which is your energy that you can't necessarily get to all the time, but it's there. That's what they're trying to say. So, yeah, plasma is everything. So, it's not exactly the same thing we think, because then the first thing when I first heard about plasma, I started thinking the light, the plasma, the light, right? I see the plasma, but that's not what they're trying to say. They're trying to say that it's a different state of matter, so that everything around it is positioned based on the amount of plasma in between it, and it's like has its own viscosity, and this stuff floats around in between it, which does make sense. So if you're going to pull a field and the energy is somewhere, it's got to be in some state, right? It's got to be, you don't have to say matter, but it builds out like a matter. So I guess I'm kind of iffy on, you know what I mean? If you could really call it matter, it's definitely has a viscosity to it. So I guess technically it is a matter. I mean, I don't know what you want me to say, man. It's not like they go out into space and scoop this stuff up. I mean, they're hanging on by a thread, explaining it themselves. Yeah, everything's a giant bubble. You're right, John. So we're in the whole cosmos is a giant bubble. There's no question about that. And in that bubble, there's individual bubbles. You know what I mean? That's why the speed of light, I don't think is right at all. I don't think that's right at all. I the time it takes for the light to get to us, they calculate right from a star. Well, I don't think that's right. I think the light is instantaneously here. I think they're going to go find. They're not traveling in time to find it. That what's going on is there's a time dilation field around that sun or every sun that you go to. That's how it's going to change the time. There's a time dilation field in that solar system. There's a time dilation field in the universe that it's in. I mean, look, you say in the galaxy that it's in. All of that exists. I don't think it's the speed of light, though. It's actually how time's working. So I don't think that that equation's right, at least not to me. Unless they explain it a lot differently than what I understand it is, then I don't know that that's right. So that's just my opinion. You don't believe in time, only timing. Well, yeah, news for you, man. Time is energy. So as soon as you create a field that has energy in it, you're creating some sort of time in it, whether that be in a linear form as you see the frequency going that way, or if you see it in a time dilation field where you got energy crossing each other, creating a barrier. There's time. Time just isn't linear all the time. That's the problem. Time is a dilation field. Most times that we see it, it's why the Earth is a different time than space, which is a different time outside our solar system. You get where I'm going with this? They're all kind of differentials in time. So, yeah, well, yeah. Oh, speed of light is not a factory in gravity time dilation. Interesting. I don't know why they even calculate the speed of light, to be very honest with you. It's not factoring in gravity time dilation. No, well, of course it's not, because they wouldn't have numbers that they do. So you're happy regardless. Right on, right on. Say all you need is compression, air, and fuel to make an engine run, but they always forget timing. Oh, you absolutely have time to timing for an engine to run. A timing belt isn't for nothing. That's for sure. Bubbles are spheres, yes, they are. I think the speed of light is instant, and I think that's the way that it works because it's a scalar field. So as it builds out the energy, it's instant between the two. If you could slow it down, I don't know if they make a camera slow enough to see if a scalar field builds out timing. Okay, as far as the distance and timing and all that. From what I've seen and can observe personally, it's instant. And it goes through pretty much everything. Yeah. Yeah. I'm not too big on the physics of entanglement, to be honest with you. You can see the light move, or you're seeing the particles in the light move. That's always interesting. Which one are you looking at? Are you looking at the particles, or are you looking at the actual light? It's always interesting to find that out because a lot of times what you're looking at when you see light is dust particles. You can see the front of the beam go out, so it's like a hold on. So it's like one of those Star Wars things where you see it shot out of the gun and then you could see it moving. Now that would be cool. If you have something like that, man, hit me up on my email and drop it on there. I'd love to see that. Scalar is just longitudinal plasma. Well, I mean, yeah. It's just think about it, but it builds out in a big field. People think of longitudinal, they got this thing in their head about this spring, man, and they can't get off the spring. And it doesn't actually build out in a spring. That's the problem. If the item in the center is a sphere, that thing is building out in a sphere. It's not just, I mean, the spring is a sphere. I mean, you got to understand it that way. They put geometry in this stuff and they screwed up because they try to make everything flat. I mean, yeah, it just destroys your understanding of things. So, yeah, in a vertical form, it would come out looking like a spring, but in a sphere form, it builds out the entire way. And it could spring like this. I'm not disagreeing with that. I'm just saying in the way that it looks when it builds out pretty much like a gas that builds out instantaneously. It goes right out. Longitudinal is much different understanding in scalar and everything else. That's why you could say the scalar field comes from the Earth and then it builds out inside the layers of the planet in the open air, because it does. And there's a temperature differential to it and there's a frequency differential to it, and it builds out that way. Much like a magnetic field builds out the same way, it still does the same thing. So the ether is a plasma we don't see because it's not amplified enough. I've seen a lot of people that say they have ether, okay, in their coils. So how do I want to say this? Is it a plasma? I call it a radiant field, okay? You can call that plasma. It kind of builds out in the same way, but it thickens on the outside. And just understand this when I say this. They build their coils so that you stack them one like this, right? And then the friction as you have the movement in the coil, it creates the static in between, right? And they stack them as capacitors like that. Could you say that's plasma? Well, I think in one understanding you can call it plasma. In the other understanding, you can call it the scalar because it builds out different levels at different frequencies. And at one level, you could just call it the radiant field that holds in the static. So they're all pretty much describing the same event, but they're said in different ways. So is it that way when they build their coils out in levels like that? Yes, it is. And that's exactly what you get. And on the outside, you get static coming out of it because you have a leaky capacitor at the end. It's still creating the friction. It still has it and still creates it on that one side. No one said you had to put static into this stuff. Static sometimes is a result of what's going on inside there. You know what I mean? It's a primary field, but when you de-amplify the other two sides of the field, which is the magnetic and the radiant portion, then you get static. Well, that's what comes out of the outside of the ends of this thing when you deal with some coils. So there's a little bit more there. I guess if you wanted to truly nail it down, then you'd have to look at every single aspect of it and see the exact way it builds out. Pretty much just a barrier in between. I mean, you could call it different forms, yeah, but it's pretty much the barrier in between. The real understanding of this is how it's flipping the fields inside of it, one to the next, one to the next. And in one instance, you're getting a static value. The next one, you're getting a radiant value. You know what I mean? You're getting the magnetic value, but it's not in the layers. It's on the outside is where you're getting it. And then it builds up. And what do you have? In the inside, you're getting a massive amount of voltage because the static can't go anywhere. So you pull out, 600, 1200 volts out of this thing because it can't go anywhere. It's trapped in the field. And you can loop this sucker. So, yeah, there's different ways to look at it, I guess. Oh, let's see. The hard part about defining this stuff is there's nothing really to compare it to. That's kind of the hard part of this. Because if I say scalar, then most people wouldn't understand what I'm saying because there's pretty much two definitions of it, right? There's scalar as in two Tesla coils sitting outside of the other with a null zone in the center, right? But if you put a coil in the center, it no longer becomes a null zone. It now picks up the energy just the same as long as it matches the frequency. But if I say scalar, it's also meaning that in the I want to say evolution. I know that's wrong. Elevation. In the elevation of the Earth, you can think of it as the heat's at the center, and then it builds out and it gets colder and colder and colder as you go. Well, the frequency also gets higher as you go. That itself is a mathematical way to see scalar. Are they both correct? One is described by Tom Bearden in the two Tesla coils. One is described by mathematics and how it builds out. Ultimately, they're the same thing? I think they are. I think you're just seeing two different sides of the same coin is what I think that you're seeing and what you're seeing build out. One describes the action around the sphere itself. One describes the distance between the two spheres. That's what I see happening there. I think they're the same process going on. It's just two different sides of the same coin. So, nice. So scalar and radiant are the same to you. In the way that you use the term radiant, I use radiant in the term as it's a field building out in something. So if I say you walk outside, right, I'm saying you're in a radiant field. So it means that energy is absolutely everywhere around you. Now, it's not magnetic, it's not static, it's just built out around you in a form of energy, right? That to me is the radiant field. What happens when you compress that kind of a field? It's a pure energy and you compress pure energy, right? It turns into radiation. That's the way I'm using that term. When I say scalar, it's building out at frequency at distance, right? Are they the same thing? If you have a radiant field, it produces the scalar field. So are the terms interchangeable? If you understand the action reaction point, yes. If you don't understand the action report, you want to get very specific, no, they're not the same thing. But does a radiant field build out to scalar? Yes, it does. So one's the action, one's a reaction. Are they the exact same thing? The answer, technically, if you had to write it down, the answer would be no. But if you build out a radiant field, are you going to get a scalar field in a sphere that builds out? Yeah, you are. So I guess technically they'd be different, but if you understand what I'm trying to say, they're not much different in the way you and I would use them. Well, yeah, lights even when the light's not on. Why? Because light's a reflection of things. Everything's dark. Light's simply the reflection. That's why. And you're absolutely right in saying that. So that's what I know light to be as well. It's the reflection of the paint. So if you say it's black paint that I have on my wall, right? Then that's just the reflective color of it. The energy is always there. So if I said it's white, then it'd be the same thing. Let's see, radiant is natural, scalar is tech. I don't believe that statement to be true. And the only reason I say that is because between planets, you get a scalar field forming in between them. And by the way, the sun has multiple frequencies in it, so it can pull multiple scalar fields. And you can see the portion of the planet, the sun that actually connects to the planet, because it's in each layer of the sun that you'll find the reflection of that planet in there, which pulls out the scalar field to that specific planet, gives it energy. It is there, and it can be seen. So I don't think that that's a tech thing. I think it happens naturally. We can create it in tech for sure. Yeah, the scalar is the field that's being produced, yes. But it requires radiant energy to do it. Well, basically, what that basically means is it means you're reducing the static level, you're reducing the magnetic level so that the field that's being present is the radiant layer, which is just energy. It's just pure energy. So if you see me doing experiments and I take an orange, right, and I cut it in half, I put a light bulb to one side and I put the field on the other, right? Yet when I bring them closer and further apart, right, you see the energy, and you know there's energy in between because the light bulb's lighting up over there, right? Well, the light bulb's just a draw in the system, but there's energy between them and acts as capacitance in that form. I mean, that's kind of why I show it, because there's more going on there. There's a dielectric that's formed in there. You say, well, one side has energy and the other side doesn't. Well, I understand that, but they have the same values inside of them, so they're going to work together. That's why I do that experiment. I mean, I don't know that a lot of people catch on to that, but there's a little bit more than just taking and playing with your oranges. I mean, you got to kind of see that. It's the same thing if you're looking at, bifilar coils. It does the same thing. You're creating capacitance in between them based on the dielectric. So, kind of building out a little bit in there the same way. Interesting how it works. There's a lot of things, man, that you could sit here and define all day long. I bet you if you want to create a definition list and sat in the room with me, you'd have several whiteboards filled up. And then you'd realize a lot of them are the same things going on over and over and over again. Let's see, electromagnetic, hold on, let me, electrostatic, electrophotonic, electrogravitic. Yeah, I mean, they're all in the same energy. Again, this is why I say it's not electrical theory. You need to say it's energy theory, because they're all present in energy theory. In electrical theory, they're not. See, we have some misguided notion based on the Steinmetz of what's in electrical. And that's why you can't define it in electrical, because everybody has a checklist. As soon as you say electrical, they have a checklist. Whether you want it to be there or not, they have it. Okay? They're going to have a checklist. There's an AC system, this is a DC system, and this is electrical. We got our checklist here. If you say something outside the checklist, you're wrong. And that's the way they'll treat it. You have to say energy, because energy encompasses all of it. Thank you. What is electric? It's just it's a compilation of voltage and amperage and frequency. That's what electric is. They do not allow for temperature differential in electric. Okay. If you tell somebody, hey, I'm going to go over to my wall and I'm going to take the wire out and I'm going to take a blowtorch to it, right? And you say, I'm going to trip the breaker because I'm going to add extra amperage to it. They tell you you're crazy. But the fact of the matter remains, you can still do it. Why? Because amperage, when it gets locked into a certain area and can't go anywhere, it creates heat, and that's what blows your breaker. Try telling that to somebody who works on the wall wires all the time. They'll tell you you're crazy. It's a fact that it's there. I mean, it's not going to, but it is there, but they don't take it into account. But then they tell you, hey, on a hot day, don't run your air conditioner, your power may go out. Why? Oh, it's just drawing too much power. No, it's creating heat in the wires, which is causing my breaker to pop. That's what's going on there. I don't know, man. Get kind of disillusioned with it after a while. I could go right over your DC system right now, change the frequency, and I'll change your volts and amps. I don't have to do anything else. I could put a duty cycle in there. I'll change your volts and amps right away. Okay? I have no problem doing it. I could change how fast it flows and the frequency it flows in by changing the temperature. It all works. I mean, it's all factual. It all will work right in front of your face, but they won't account for those things. You say, well, I'm going to create resonance, right? Well, I'm going to create resonance in this coil, and this coil is going to gain resonance, and it's going to shoot out plasma. And they're going, there's no way it can do that, right? You can't create plasma out of nothing. It's doing with frequency. But yeah, it does. It does create plasma out of it with just basically frequency. Why? Because it's a harmonic. And when you get into harmonics into string theory, it's absolutely a fact. I mean, there's a lot more than what they want you to think there is here. And there's a lot of facts that go into this. So, resonate with what? Anything. If I can, okay. If I can create something in resonance, and just understand this, it's two frequencies, okay, that are at the same frequency to each other that causes resonance. Now, this is something that in physics they tell you as soon as you have the same frequency and then the same exact amplitude, they cancel each other out. Well, do they? Because they don't. They resonate. And they start resonating. What happens? Then you find another thing that's in that same frequency as the resonance frequency. Not the frequency, but the resonance frequency. The frequency it creates between the two. Guess what happens? It starts to excite it, and it gives it energy. It's a fact. Okay? That's the way resonance works. Now, there's a resident frequency, which is the maximum value that energy can get in resonance, which basically means if I were to take my piezo and pulse it in there, I get a resident frequency. That's what I get out of my jewel thief when I hit the button. It doubles the value. Why? Because it's a resident frequency. It's a maximum value that I can possibly get out of the resonance. So, yeah, that's just pretty simple, straightforward. It's proven. It's on the channel if you want to watch it. But it's something that they're not seeing. Okay? They think that the frequency cancels each other out, but not when they're pulsed. As soon as you pulse one to the next, you now have resonance. It's not a cancellation at all. By the way, oh, it boggles my mind how they do this. Okay? You cannot just start canceling stuff in a system. And here's what I mean. If you have a frequency in the system that matches another frequency in the system, it doesn't cancel. It just means that there's a value attached to it in a framework, right? In each side of it. There's no cancellation going on there. It's like in energy, multiplying times zero never means that the answer is zero. It still has a placeholder value. Okay? It means that your multiplication amount is zero. That's correct. But the original value stands. You know, I think Terrence Howard tried to say this, and he gave the wrong example. He gave it in a triangle, and you got to do 1/2 base times height in order to have a correct value in it to show that there's a value in the triangle. He had his math formula wrong. But what he was saying actually made some sense into it is that the original value is still there, but if you multiply it by something, it's a multiplication that goes nowhere, but the original value is still there. I agree with that. It's not zero. In math, it works great. Oh, it's just a times table. Anything by zero is zero. That's not how energy works. That's not how it works. You got to have a continuous value in there. That's why I never cancel anything out in the system. I just put it in there and write it as this is a system, and then this is another system. And this system may have the same frequency as this system, but as soon as I change a value in my magnetic just on one side of it, it'll absolutely change that. So if I eliminated it from there, I'd never see that. And in the end, my experiment would fail. I don't know if that makes sense to you, but you have to have a place value status in some of this, right? I think in math, it works out great. It's convenient. But in energy, it's not. It actually ruins your whole thing. So... it's you can have nothing is what Terrence meant. Everything is in motion. You never have zero. I guess that's one way to see it, but he used a specific saying when he said the triangle, right? And he was trying to say if you say it's 4 over here and 0 on this angle right here, right, then it gets a 0, right? Well, it would never work in a triangle that way, by the way. It's impossible to have a 0 value on something. It was just a bad example all itself. So maybe you're right. He was trying to say something different. So, oh, it's not like eating the apples are running out. Love it. Nice. Yeah, the harmonic continues. You can, that's a hard way to think about it. Well, yeah, math is great for a lot of things, and I love math. Okay. But you have to realize when you need to put a placeholder value in there, or if you need to put a word in there instead of it just to say what that line is continuously, it always has to be there. Sorry, it doesn't get to just get canceled out. I've never liked the zero term in math when it comes to multiplication, because if you divide it, it's still there, right? You multiply it, well, then the multiplication value is zero, but it doesn't mean you don't have the original two. If if I had 2 quarters and you say, well, I'm going to multiply it by zero, right? Well, that's fine, but I still have 2 quarters. They don't just disappear out of my pocket. You know what I mean? Unless you're trying to take my 2 quarters, it just doesn't disappear. Okay. It still has a placeholder value. Now, if you divide my quarters, I have 25 cents. Okay. I have two. So maybe just a misunderstanding on my part. Who knows? Some of this stuff gets old to go over, guys. It really does. I always put a placeholder value. Why? Because in energy, if you don't put a placeholder value in it and you get to it later on and you try to zero something out, guess what? You're left with a bad equation and a failed experiment. It's easier just to go back and look at it again and you say, why did this experiment fail? Well, it failed because I didn't account for something. Well, that's usually the anomaly that it fails. Because why? Because somebody will pick up a little bit of heat in the system, pick up an extra amperage, right? Maybe it's just a little bit and it builds over time, but everything builds over time, builds to a certain level until it put things out of resonance. That's when you start having trouble. That's when people usually fail and they go back and look at their math and they say, man, my math is correct, right? Well, is it? Did you account for that anomaly? And you say, well, it's too small, it's infinitesimal. Well, it doesn't build infinitesimally, it builds on a scale. So it's changing the value, and it gets worse in a DC system. Okay. In an AC system, you might get away with it quite a bit. In a DC system, you can't. Why? Because as soon as I build the amperage a little bit, I'm bringing down my frequency a little bit, right? And I'm bringing down my voltage itself. Now you're really screwing the pooch. If you're trying to loop something, you've got to be accountable for that. So, yeah, sorry. Just where I see it. Man, you are awesome, Tim. Thank you very much for that, man. I really do appreciate it, brother. Right on. Tim been checking in with me throughout the week, man. I see him watching the videos and stuff, hanging out. Right on, brother. Thank you for that. I really do appreciate it. Nice. Very good, man. Right on. Yeah, a lot of this stuff, man, they get to, and a lot of this, and I deal with a lot of electrical theory and resonance, man, which is a lot different than some of the stuff they deal with. And I'll always give them credit. You're welcome, brother. Thank you, man. You're awesome. Awesome. Right on. Yeah, I do. Like I said, I deal with a lot of resonance and a lot of frequency and flipping things between them. Obviously I work on my little gravity flyer project, which I think a lot of people do, and try to find out the secrets of the mysteries of the universe like everybody else. And I run across things that don't work out the way they say they're working out. And yeah, right on, brother. Right on. And I like to point them out because people then can think about it in the right way. And if I tell you something, it's because I've done it. I've seen it. I've built the experiment to show it. There's a lot of people out there that'll tell you a lot of things, but they'll cite a formula. They'll cite a theory. I'm citing the actual fact that it's done. So it kind of makes a little bit difference. That doesn't make me better than anybody, that's for sure. I know that. It just means that I did the work. That's all it means. So, not that I'm better than anybody, because I don't see people that way. I see everybody at the same level. I don't care what you're doing. Well, unless you're a murderer or something, then we don't see eye to eye. I think that's for everybody, though. Yeah, brother. No, it's you. You did good, man. Thank you. Yeah, everybody in this group, man, does good. Like everybody, man. I gotta say, out of everybody, man, this chat and the way we conversate, and I try to get to every question that I can. It's truly different than anybody else's chat, man. I like it that way. I like everybody involved in it. So right on, man. And I always try to show you guys videos, man. Yeah, by the way, I gotta mention this. It's your capacitors that are driving me nuts. Okay, just so we know, Dennis. Because he used the original capacitors from the ZBS board, he's getting a different frequency. And I bet you if you put your oscilloscope next to the frequency on that, it's not going to match mine at all. And I think that's what it is. The frequency's in more coordination with your phone. That's what I think's going on here. I've tried my camera every which way, but I'm at like double the frequency you are. So it's not slow enough to match your thing. See, there you go, 209 kilohertz, right? When I run my Tesla coil, I'm anywhere between 270 to 302, 310. Massive difference in the kilohertz. So your speed captures that on camera better. I gotta get off my lazy butt and put those other capacitors in there and see what you got. That's what I need to do. Sometimes we don't realize things when we build them that you kind of went in the wrong direction, and I have to put my hand up and tell you 100% was wrong. So yeah. Dirty and blinks. That's so cool though, because you're getting a lot of the colors, man. That's rad. I love that, man. You're getting a lot of different colors going on in there. Blinks, yeah. But it's the color thing that you're going through the spectrum. That's what's cool, man. 209. All right. Now you gave me something to hit. I'm going to change my capacitors and look for 209. I'll see if I can't do it. I got it hooked up to my gravity flow. I got to finish some experiments out there. But as soon as I'm done with that, man, I'm going to look for that 209. Nice. I'll put it up here so everybody sees it. Yeah, you got me on that one. I was trying to figure it out, going crazy, pulling out my hair, setting my camera and all different things. And it was that. It's the frequency. And I should have known. Let's see. My Galaxy 24 Ultra Slow can take picture vids closer at 18 inches. Nice. Dude, by the way, Darren's been running his coil forever, man. If you guys haven't heard that, he's been running that thing all day. That thing is that coil's mean, man. And it acts totally different under ZBS than it does the Slayer Exciter circuit. The Slayer Exciter put out energy everywhere. ZBS, man, it's very specific in that frequency. Yeah. Dude, right on. All right, guys, it's been about 3 hours or getting close to it. I'm going to take off, man. You guys have been awesome today. Hey, let me just say again, man. Thank you out there to Tim, man. You're awesome, brother. Totally taking care of business, taking care of me. Thank you. So, with that said, man, everybody out there, have yourself a great night. I'll see you guys again on Wednesday. If you got more questions, by all means, let me know. I don't think Sean's going to be here this week. It's going to be me. And I think Joe comes back on Friday. So, it'll all work out, man. By the way, in case you guys didn't know, we do sell T-shirts for the for everything around here. So I'm going to go ahead and put that in the chat right now. And there you go. You can get an Old Man Builds T-shirt. You know what I mean? Totally awesome. I also sell the Tesla coils, like the one you see right here over my shoulder. I sell them as a complete kit with all the power pack and energy thing. I had to change the price just to make sure everybody gets it right. And whatever my feelings are of it aside, at least you have a complete kit. So anyway, with that said, man, have a great night. And thank you guys, man.
The old man built. 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 builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.